Welcome, curious minds, to The Other Opinion. This is the place where we really don't shy away from those interesting, maybe sometimes less talked about perspectives.
That's the goal.
And today we're doing a deep dive into a world where standing still, well, it's just not really an option. We're talking about programming.
The dynamic, always changing world of code.
Exactly. And our mission today is to unpack why in this field that phrase, "don't take breaks," isn't just, advice. It feels more like a necessity to stay relevant, to stay effective.
It really is. And we're going to explore how that continuous learning, really understanding the fundamentals, and keeping up with how tools evolve, well, it's all crucial if you want to thrive.
Definitely.
And we pull from a whole range of great sources for this. Insights from JetBrains, HiE, Stack Overflow communities, which are always buzzing.
Oh, yeah.
Coursera for the learning side, TIOBE, and Pluralsight for rankings, and some great analysis from IT Imagination and Geeks for Geeks, too.
So it's a pretty wide net, and hopefully all that gives us a really comprehensive look at the languages, the hardware underneath, and how it all keeps evolving.
Yeah, it helps highlight what actually matters if you want to stay ahead, connecting the dots.
Seeing that pattern of constant change.
Exactly. Constant adaptation.
Okay, so if you're ready to get into the nuts and bolts of code and hardware and understand why "don't take breaks" is kind of the programmer's imperative, make sure you like this deep dive.
Please do.
And subscribe to The Other Opinion for more explorations like this.
Oh, and share it with anyone who's curious about tech. Let's get started.
Let's do it.
So to really get why staying current is so vital, maybe we should trace the journey of programming itself right from the start.
Good idea, because the roots go way back.
Yeah.
Further than most people think.
Right. Like 1843. Ada Lovelace.
Yep. And her genius wasn't just writing that first algorithm for Babbage's analytical engine.
No, it was seeing beyond just calculation. She envisioned it as like a general-purpose machine. That conceptual leap was huge. It basically freed computing from just being a number cruncher, right? And it forces us, even now, to constantly rethink what's possible.
It really does. And then there's the theoretical side.
Alan Turing, 1936. His paper on the universal machine, that's the blueprint.
The idea that one machine could basically do any computation with the right instructions.
Exactly. The foundation for pretty much every computer we use today. It all stems from that idea.
And then actually building something? Konrad Zuse.
Right. Early 1940s. Plankelcool. Considered the first actual programming language for computers.
Designed for repetitive tasks, making things efficient.
Yeah, moving from the abstract to, code that actually did something. That kicked it all off.
So how did we get from that to languages people actually write in today? What was the big shift?
Well, a key step was assembly language around 1949. It used mnemonics, making instructions a bit easier to handle than raw machine code.
It's still pretty low level, though.
Oh, definitely. But then autocode in '52 was a big deal. It was the first compiled language translating human-readable code directly into machine code.
Okay, that sounds more like programming as we think of it, more human-friendly.
It was a huge step.
Yeah.
And the '50s, well, that decade gave us some real giants.
Yeah.
FORTRAN, 1957. John Backus's team.
Still used, right? Which is kind of mind-blowing.
It is. For scientific and mathematical stuff, especially in supercomputing, it's just incredibly efficient for those complex simulations.
Amazing longevity. And COBOL, that's another one that just hangs on.
COBOL, yeah. Common Business-Oriented Language, 1959, led by Dr. Grace Murray Hopper, a legend.
Built for business needs.
Right. Think banking, credit card processing, even traffic signals, phone calls back then, and today. It's still running a lot of the world's financial infrastructure.
Why? Why hasn't it been replaced?
Honestly. It's incredibly robust and stable for what it does. Replacing those core banking systems is massively expensive and risky. So COBOL just keeps going. It's like the ultimate example of don't take breaks, because replacing it is the break nobody wants to take. That makes sense.
Okay, let's jump ahead a bit. The 60s and 70s, things start opening up more.
Yeah, definitely. BASIC in 1964 was designed specifically to be simple for beginners. Later, Bill Gates famously marketed it.
Made programming more accessible.
Exactly. And then Pascal in 1970, Niklaus Wirth. It was praised for encouraging good, structured programming habits. Early Apple computers even used it. Clarity, structure that was becoming important for reliability.
Okay, and then 1972, you mentioned that was a big one.
Oh, 72 was a vintage year. Just massive influence. Dennis Ritchie at Bell Labs creates C.
C, okay, that's foundational.
Totally foundational.
Yeah.
Languages like C#, Java, JavaScript, Perl, PHP, Python, they all owe a huge debt to C's principles.
And it was tied closely to Unix, right?
Yep, that partnership was revolutionary for building operating systems and software. Game changer.
What else from 72?
Smalltalk also arrived. It really pioneered object-oriented programming concepts, ideas that are now fundamental in Java, Python, Ruby.
So organizing code differently.
Precisely. And then SQL, Raymond Boyce and Donald Chamberlain, structured query language.
For databases. Still the standard, basically.
Absolutely. For managing and asking questions of all that data that drives everything now, social media, business intelligence, you name it. So yeah, C, Smalltalk, SQL, all in 72. Monumental.
Wow. Okay, so moving into the more modern era, what languages really shaped the computing we experience daily?
Well, the 80s brought things like ADA, named after Ada Lovelace, appropriately,
Yeah.
still used in critical systems like air traffic control in Europe, even some space stuff because it's so reliable.
High-stakes stuff.
Definitely. And then C++ came along. Bjarne Stroustrup built on C, adding object-oriented features and more power. It became dominant for high-performance software. Think MS Office components, Adobe Photoshop.
Heavy lifting.
Exactly. But the 90s, that's when the internet age languages really exploded. And many are still top dogs today, forcing that continuous learning curve.
Right, things really started moving fast then.
For sure. Python, 1991, Guido van Rossum, it just soared. General purpose, high level, relatively easy to learn.
Used everywhere now. Google, Spotify.
Yep. And its simplicity and power made it explode in AI, machine learning, data science, web development. It's just incredibly versatile.
And 1995 seems like another huge year, especially for the web.
Oh, massive. You've
Yeah.
got Java from James Gosling. That whole write once, run anywhere idea was revolutionary.
Runs on so many different devices.
Cell phones, parking meters, huge enterprise systems, Android apps, big data tools like Hadoop, financial servers.
Yeah,
It's everywhere.
okay. And JavaScript, also 95.
Yep, Brendan Eich. Absolutely essential for making websites dynamic and interactive. Almost every major site, Google, Facebook, YouTube, relies heavily on it.
You basically can't use the modern web without it.
Pretty much. Yeah. And PHP, also 95, Rasmus Lerdorf. Crucial for the server side, building web pages dynamically empowers huge platforms like Facebook, Wikipedia, WordPress.
So those 90s languages really built the internet we know and meant programmers constantly had new tools, new paradigms to learn.
No question. The pace just accelerated. Don't take breaks became the default.
It's easy to get lost in the languages, isn't it? But the code needs somewhere to run. It needs hardware.
Absolutely. The physical foundation.
And understanding that evolves, too. It's another way programmers kind of don't take breaks. They have to keep optimizing for the actual machines.
True. You need to know what your code is actually doing down at the metal level sometimes.
For anyone really wanting to get that connection, I always recommend Charles Petzold's book, Code, The Hidden Language of Computer Hardware and Software.
Oh, fantastic book. Really breaks it down.
Yeah, he starts simple, like with electrical circuits, and builds up layer by layer to complex systems.
His approach is great, using things like Morse code, Braille, Boolean logic to explain the concepts behind vacuum tubes, transistors, integrated circuits.
Shows the journey, the dead ends even, like mechanical computers before we got to the electronic binary systems we have now.
Yeah, it gives you that crucial context, why things work the way they do, which is invaluable for a programmer.
So when we talk core hardware, what are the absolute must-knows for a programmer today? Why does it matter for their code?
Well, number one is the CPU, central processing unit, the brain, basically.
Does all the thinking.
Fetches instructions, executes them. It's built on silicon, billions of tiny transistors acting as switches. And the trend now is multi-core.
More brains working together.
Right, which means programmers need to think about writing code that can run in parallel across those cores to get the best performance. That's a key challenge.
Okay, CPU. What about memory?
RAM, random access memory. That's a computer's short-term volatile workspace, like your desk.
Where active programs and data live.
Exactly. Usually DRAM chips for the main stuff, faster SRAM for the CPU's cache. Understanding that hierarchy cache is fastest, then RAM, then storage is vital. Efficient code tries to keep needed data in the fastest possible memory.
Minimizes waiting. And permanent storage.
That's your storage devices. Old school hard disk drives, HDDs since '56, or the much faster solid-state drives, SSDs, using NAND flash since the '80s.
Non-volatile. Keeps data when the power's off.
Right, and the speed difference matters. SSDs mean faster boot times, faster application loading, quicker data processing. Your code might behave differently depending on storage speed.
And the thing holding it all together.
The motherboard, the big circuit board connecting everything CPU, RAM, storage, graphics card, peripherals. It's the central hub, the nervous system.
Got it. And one more thing often overlooked.
Cooling, super important, especially now. CPUs, GPUs, they generate a ton of heat.
And heat slows things down.
Absolutely. It causes performance throttling. Your super optimized code won't run fast if the chip is overheating. Fans, heat sinks, liquid cooling, they're essential. Managing power and heat is actually a huge bottleneck in hardware design.
So even seemingly simple things like cooling directly impact code performance.
Yeah.
Understanding the machine helps you write better code.
Precisely. Knowing the constraints lets you work within them effectively.
Okay, speaking of effective code, let's jump to now, 2025 and beyond. What's the programming landscape look like? TIOBE index, plural site rankings? Who are the big players programmers can't ignore?
Well, Python is still king, number one pretty much everywhere you look.
Still, wow.
Its dominance in AI and machine learning is just massive. Think self-driving cars, those ChatGPT-like models.
Yeah.
It's Python underneath a lot of that, plus data science, web dev, and sim. It's just so versatile and relatively simple.
Incredible run. But Java and JavaScript aren't going anywhere either, right?
Not at all.
Yeah.
Java is still the backbone for huge enterprise apps, banking, supply chains, also Android apps, big data tools like Hadoop and Spark, games like Minecraft, IoT devices, financial servers. Its platform independence is still a major draw.
Write once, run anywhere still matters.
It does. And JavaScript. It basically is the interactive web. Something like 99% of websites use it. Google, Facebook, YouTube. If it moves or updates on a web page, JavaScript's probably involved.
Essential skill for web devs? What about performance critical stuff?
That's still C++ territory. And C++ for games, high-frequency trading systems, operating system components. It's harder to learn, maybe, but gives you that raw speed and control.
NC?
C is still fundamental. If you really want to understand computer architecture, operating systems, hardware drivers, you learn C. It's low level, forces you to understand the machine. It ranks high on TIOBE for a reason.
So the old guards are still strong. What about newer languages making noise? The ones forcing programmers to adapt now?
Go, or Golang, is definitely one. Developed at Google. It's designed for building scalable systems, cloud services, microservices. Companies like Uber, Dropbox use it heavily because it handles concurrency really well.
Doing many things at once efficiently.
Exactly. And Rust is another big one. It's gaining traction fast, especially for systems programming where memory safety is critical without sacrificing performance. People love its safety features.
Less prone to certain types of bugs.
Right. And Swift, of course, for Apple's ecosystem iOS, macOS apps. It's modern, safe, performant. So yeah, Python, Java, JS, C++, Odyssey are the giants, but Go, Rust, Swift, they're pushing the boundaries, making programmers learn new tricks.
Okay, this is where things get potentially disruptive. AI's impact, you hear it everywhere. AI is the ultimate productivity hack for developers. Is it hype?
Oh, it's definitely not hype.
Yeah.
It's fundamentally changing how software is developed.
Yeah.
This might be the biggest don't take breaks driver right now.
Absolutely.
Intelligent code assistants, think Microsoft Copilot, Cursor, Google's Gemini Code Assist. They're boosting developer productivity by like 20 to 70% in some studies. That's huge.
70%. Wow. How?
They suggest code snippets, autocomplete functions, even write whole blocks of code based on natural language prompts. They're trained on massive data sets of code from languages like Python, JavaScript, Java.
So it's like having a super-powered pair programmer.
Kind of, yeah. But it also shifts the programmer's role, you know?
Oh.
Less time on boilerplate syntax, more time on higher-level design, architecture, reviewing and integrating the AI suggestions, problem solving.
So it's not just writing code faster.
No, it's changing the nature of the work, and AI is automating other parts too, generating test cases, finding bugs humans might miss, even helping with project management, predicting timelines, allocating resources.
Okay. And MLOps, AI ops, what are those?
Basically, they're practices for managing the life cycle of machine learning and AI models efficiently. Think deploying, monitoring, updating these complex AI systems at scale. It bridges data science and traditional IT operations. It's about making AI reliable and manageable in production.
So AI isn't just a tool for programmers, it's also something they need to manage as a product. More to learn.
Always more to learn.
Okay, beyond AI, what other big trends are shaping software development in 2025? What else means you can't afford to take a break from learning?
Cloud computing is just table stakes now. AWS, Azure, Google Cloud are dominant. Understanding how to build, deploy, and manage applications in the cloud using tools like Kubernetes for container orchestration is essential.
Everything's moving to the cloud or built there from scratch.
Pretty much. Then there's low code and go code. that's growing incredibly fast.
Letting people build apps without writing much code?
Exactly. It speeds up development, lets non-programmers build things,
Ah,
which means professional developers need to focus on more complex integrations, custom logic, the stuff low code can't easily do. It pushes them up the value chain.
interesting. What else?
DevSecOps is huge, integrating security right from the start of the development lifecycle, not tacking it on at the end. And microservices breaking big applications into smaller independent services. Tools like Docker make this manageable. It improves scalability and maintainability.
Makes sense. More flexible.
Definitely. The Internet of Things, IoT, is still exploding, connecting everyday objects, industrial sensors. The economic impact is projected in the trillions, and 5G is fueling it with faster, more reliable connectivity.
So, programming for tiny devices, managing tons of data streams.
Yep. And finally, cross-platform development.
Yeah.
Tools like React Native or Flutter let you write code once and deploy it on both iOS and Android. Huge efficiency gain.
So many different areas constantly evolve. I mean, it really feels like that don't take breaks. Mantra isn't about burnout.
No, not at all.
It's about staying agile, right? Continuously learning, adapting. The whole field, from quantum computing experiments way out there to AI writing more and more code, it's just relentless change.
That's the perfect word, relentless.
Uh-huh.
Embracing that continuous learning, adapting to these shifts, it's not optional anymore. The very definition of programmer is evolving as we speak.
Wow. Okay, that was a lot to cover, but super fascinating. If you found this deep dive valuable, please do subscribe to The Other Opinion. We explore these kinds of complex topics regularly.
And hit that like button. It really helps us out.
Yes. And comment below, what are your other opinions? What trends are you seeing? What did we miss? We'd love to hear from you.
Definitely. And share this with your tech-loving friends.
So, wrapping up, it seems clear the world of programming demands constant motion. Don't take breaks. Really means embrace that lifelong learning. You need to understand the hardware, the software, the new tools like AI.
And use them to stay on that cutting edge.
Couldn't have said it better.
And here's a final thought to leave you with. As AI gets better and better at handling the routine coding tasks, what happens next? What new creative challenges, what new frontiers will human programmers explore when they're freed up from some of that drudgery? How does that redefine what being a programmer even means over the next decade? Something to mull over.
Definitely something to think about. Thank you for joining us on this exploration here on The Other Opinion. Please like, comment with your other opinions, and subscribe.
Thanks, everyone.
And just a quick note, this deep dive was crafted using AI assistance, aiming to provide information and alternative perspectives based on our sources. While we aim for accuracy, some information might be incorrect. Always good to double check. We'll catch you in the next one.